For this lab you'll need 4 beakers, each containing acetic acid, distilled water, a buffer with a pH of 4, and a buffer with a pH of 7, and a pH meter. Today we're going to be doing...
You put your goggles on!
Oh god!
Alright, today we're going to calibrate our pH meter. For this we're going to need 2 buffer solutions. One of them with a pH of 7 and one with a pH of 4. Alright, let's go into sensors and calibrate. Okay, now let's hit calibrate now. Alright, let's take the electrode and put it in our buffer solution with a pH of 7. Now, right here, let's type in that the pH is 7 and hit keep. Now, take the electrode out and rinse it in distilled water and make sure to dab it and not to put much force on it because it's very delicate. Now put our electrode in the buffer with a pH of 4 and enter what our solution is and hit keep.
Now we're going to test our buffer solution. First, let's start with the buffer with the pH of 7.
What else do I say?
Now we're going to take the electrode and clean it in distilled water. Then lightly dab it dry. Then stick it in pH 4.
Find the pH of our unknown, in this case acetic acid. Let's start by rinsing our electrode in distilled water, and then dab it lightly in paper towel. Now you put the electrode in the acetic acid and see what the pH is.
Now to clean the electrode, we're going to dip it in distilled water and lightly blot it on a paper towel. Then you're going to place it back in its solution cap. Now we're going to turn off the machine by pressing the power button.
Keep it held.
And unhook all of the wires. Now let's wrap up all the wires and place it back.
In a strong acid, shown on the left, protons completely dissociate from the acid when added to water, which causes the pH to be lower, whereas in a weak acid, shown on the right, the protons do not completely dissociate, which causes the pH to be higher. So in its equilibrium, the strong acid will have more H3O ions on its product side, whereas the weak acid will have less H3O ions, which causes its pH to be higher or lower. So, me and my friend are walking down the street, and I turn to him, and I'm like, hey, I think I lost an electron. He's like, are you sure? I'm like, I'm positive! Pure solids and liquids are not included in the equilibrium constant expression because the equilibrium is affected only by the changes in concentrations of reactants and products, not by the amounts present. And because solids and liquids have constant concentrations and don't change with the amount present, they can be easily factored out of the equilibrium expression.